Before getting fully into this slideshow, there are four people whom I would care to acknowledge. The first is Brett Brooks, who used to race an RC51, and he very kindly gave me a copy of the 2000 workshop manual. I really don't think I could have done this project without that, because I cannot work from a PDF or even a printed PDF. The second is Roger Ditchfield, the sole owner of Revolution Racing UK, and he was extremely willing to give me his time and knowledge. Third one is Seth Sinclair, who took my design for the new rotor mounts for the front wheel brakes and turned it into a DXF file that I could send to SendCutSend for laser cutting. And finally there is Scott Wolf, who supplied the beautiful clear clutch cover to show off my Yoyodyne slipper clutch. Obviously he didn't make that just for me specially, but it was just a very beautiful thing to be able to buy and fit to the bike, a sort of finishing touch. Here is my completed 2000 SP1 restoration project. I do have the original fairings, however they're pretty badly damaged and in need of repair. So I chose to buy a set of cheap Chinese fairings for everyday use and perhaps some use on the track. I think that these fairings are particularly good looking, and I also like the fact that they lack the headlight apertures. Honda introduced the RC51/RVT1000R as a homologation special in order to be able to race a 1000cc V-twin in the World Superbike Championship Series, taking on Ducati at their own game. They were successful and in fact beat Ducati in the first year of its introduction, which was 2000, winning the World Superbike Championship with Colin Edwards and repeating the feat also with Colin Edwards in 2002. Furthermore, in 2002, Nicky Hayden took an RC51 to the AMA Superbike Championship victory, collecting a Daytona 200 win on his way. So here it is. I think it's an extremely fine machine, both good looking and good performing. I had a VTR 1000F back in, shall we say, the last century, and I always enjoyed that bike. I think it's one of the best sport bikes anybody ever made. It may not have been the fastest, but as a looker and an all-round machine, and especially tractability on the throttle, it was just absolutely brilliant. And the RC51 is equally good, albeit, as you might expect, rather more hard-edged. I feel privileged to own one of these machines. Here we are at the beginning of my adventure with the Honda RC51. This bike had been advertised as a Nicky Hayden special, and in fact it does have a tank that almost certainly did come from a Nicky Hayden special, but as it turned out, once I'd learnt more about the details of the variants of the bikes, I realised it was not, and in fact learnt that it was a 2000 model. The young man I bought it off of had crashed it between the first time he posted it for sale and the second time, and the price was dropped to $2,500, and I managed to get that down a little bit further. It's a strange thing to say, but I'm glad I bought it from him, because it actually was in lethal condition, and I suspect by buying it from him I probably saved his life, and you will learn more about exactly why it was in a lethal condition later on. Suffice it to say that some of the modifications that had been done to it had been absolutely botched, and it was just lethal. Here I'm getting ready to remove the swing arm and lift the frame off of the engine. The bike had obviously suffered something like running over a 4x4 at speed, and there was a pretty good dent in the front rim. So here I am getting set up to pull the dent out. Most of you will probably realise that this wasn't going to work the way I've shown it, and what I wound up doing was wrapping those two wooden blocks in aluminium sheet and then using a big propane torch to heat the rim under tension until it moved, and this was quite successful. I ended up getting the wheel running within about 3mm, which is slightly outside the specified tolerance of 2mm, but pretty good. The next picture shows the other end of the come along anchored off to my vise. So basically the procedure was to put a whole lot of tension on and then apply heat until I saw it move. And the thing about doing this with aluminium is as soon as you take the heat away, it'll stop moving, providing you haven't overheated it. So yeah, quite successful. There's evidence later for the vertically upwards impact in pictures showing the bent clip-ons and the upwards dented radiators. Here is the tarted up rear wheel from an R1. The front wheel is from an R6. The difference between the R1 and R6 front wheel simply being the rotor diameter, which on the R6 is 300mm and thus too small for an RC51, and I addressed that issue later on. The weight savings are approximately 4 pounds 6 ounces at the back and 15 ounces at the front, which is a good weight saving perhaps for on especially since it's unsprung weight. It's a shame the installation was completely botched and in fact extremely dangerous, and I'll explain the situation with the rear wheel in the next slide. The R1 rear wheel has a spindle diameter of 28mm, which you can contrast with the diameter of 25mm for the RC51. And you can see here that this was addressed by somebody by just gouging the hell out of the slots in the swing arm using a die grinder or something of that kind. And this was compounded by the shortness of the Yamaha axle, and that was not properly addressed, so the wheel nut was simply screwed on loose and a hole drilled straight through and an R-pin put in, so the whole rear wheel was completely loose. You could shake it back and forth and you could shake it side to side, and that's why I describe it as being lethal. So what I did was to rebuild the slots using a Lumi-Weld from Harbour Freight. Very tricky to do, but nevertheless I was successful, and I carefully filed them out to the 28mm diameter for the R1 spindle. While I'm on the subject of botched installation of replacement wheels, the front wheel, apart from being dented, carries the R6 rotors. The R6 rotors are not only 1 centimetre too small in diameter, but they are 5mm too far in on each side, which meant that the brake calipers had to be spaced. So talking about spacers, the spacers for the front wheel were not perfectly parallel, somewhat wedge-shaped in fact, and the consequence of that is that when you torque up the axle, the bottoms of the forks are going to try and conform to the non-parallel spacers, with the result that the fork legs try to bow a little bit and effectively the front forks ended up being wooden. Here we can see fairly severe scoring of the rear cylinder, and it did measure about 40 pounds per square inch down compared to the front cylinder. As I understand it, such scoring can be caused by wheelie popping acceleration from cold. However, the Honda aluminum cylinder finish is known to be a little on the soft side, and I addressed this issue later on. Here are the cams, tappets and adjustment shims from one cylinder. The cylinder cover still has the secondary air feed valve body on it, which is blocked off with silicone goop. Later on I make some proper block-off plates. Here we can see vertical impact damage to both radiators, and unfortunately, as you might expect, the tubes were in fact cracked, rendering the radiators useless. Also, you can see both clip-on tubes which were bent downwards, and the picture of the clip-on in the lathe really illustrates the extent of the impact. I would have thought that could be enough to break wrists. It certainly would leave very sore wrists, but this damage is definitely consistent with a vertical impact on the front wheel. Here's a picture of me messing around with a laser that throws perpendicular lines onto my newly painted frame, working to establish exactly where the centre of the frame is, and moreover where that centre will transfer back onto the swing arm, to ensure I get the back wheel in the middle, because the spacers need completely reworking. Fork internals. Compression adjuster from the bottom of the fork leg. Here I am indulging in one of my unfortunately many moments of stupidity. What I'm attempting to do is to unscrew the cylinder off of the rear shock, and stupidly I hadn't noticed that there was a little grub screw locking the thing into the shock body, and I did in fact manage to get it unscrewed. The next photograph shows me with the cylinder and the lathe picking up on the thread and just very carefully chasing it out to get it clear. I subsequently had the cylinder replated. Here we are looking at the seal head from the rear shock and the K-Tech rear shock rebuild kit. Unfortunately, I don't seem to have kept the slides showing the sequence of the shims during the rebuild. Unfortunately, that's just too bad. I also don't have the slides showing the removal and reinstallation of the spring, which was quite difficult. Here I'm getting ready to suspend the engine from a tree so that I can blast it and paint it working at a decent height rather than down on the ground. As you can see in the third picture, it came out quite nicely. There is a clear coat over the paint there, which has the advantage of making the engine a little bit easier to clean. Here's the rest of the engine waiting to be fitted. I deliberately left the cylinder heads off before installing the engine into the frame, because it reduces the weight of the engine quite a bit. I did remove each valve and give it a very light lap with grinding paste. This was probably not necessary, but since the engine has got 40,000 miles on it, it seemed to me that it was probably a good idea. Certainly the leak down tests and the dynamometer results at the end were very, very satisfactory. Here is the newly painted frame waiting to be lifted onto the short engine, and then the short engine being set up on blocks in position and the frame lowered down onto it and the through bolts refitted. There were a couple of problems with the replacement Chinese radiators, the worst of which is that the filler cap was standing up too high and would prevent the fairing from being fitted. So what I did was to cut it off and lower it down, so that the stub on the filler neck now actually went into the tank rather than sitting on top of it, and then had it TIG welded and back into position, and as you can see, that worked. As regards the fan, it's also well known that the efficiency of drawing the air in through the side of the fairing is pretty poor. So I elected to reverse the flow. Now, of course, you can't just simply reverse the polarity of the motor, because now the fan will be turning in the opposite direction to its aerodynamic direction. And so what I did was to take the actual fan impeller off, press the little hub out of the middle of it, and make a new hub so that I could put it back onto the motor the opposite way round. That was very successful. Showing the swing arm reunited with the frame, with the swing arm pivot going through the back of the crankcases, forming an extremely solid connection. In fact, some people would have said that the connection was too solid, and one criticism of the SP1 version was that it was hard for a rider to feel for grip at the rear tyre. Showing the rebuilt shock with the repainted spring and plated components. I think it looks pretty good. Here I'm trying the OEM plastic back on the bike just to get a feel for how things are coming on. As mentioned before, the Honda rear axle is 25mm, whereas the R1 rear axle is 28mm. And you can see the difference here. What I had done was to actually turn a sleeve to go over the Honda axle to step it up to the 28mm, but ultimately I decided to go with the R1 axle. The problem being that the R1 axle is a bit too short, and so I had to thin out the chain adjuster blocks at the end in order to be able to properly fasten and torque up the axle nut. The spacers here is just where I'm playing around trying to get the wheel in the right place, and of course the alignment of the chain and the brake caliper. Once I got all that done, I remade the spacers as sort of single piece units. So here's the wheel, looking mighty fine in the swing arm with the chain around it and everything. I'm just looking at the length of the chain. I changed the drive ratio from the stock 16:40 to 15:42, which seems to be a pretty popular choice. If you look closely, you can see where I've machined down the left hand chain adjuster block to allow for the shorter Yamaha axle. So to a point this picture tells its own tale. I managed to break off one of the camshaft cap bolts. The thing I'd found with those bolts is that, first of all, they don't recommend replacing the bolts in the manual. However, the recommended torque does actually cause the bolts to seem to wind round an awfully long way before the torque wrench clicks too far, and I was pretty sure I was going to have a problem, and yes, indeed I did. Luckily, I was able to drill into the remaining stub of the bolt and get it out with a screw extractor, which is a fairly rare success. When I finished the job with the camshafts up, I put the bolts in a couple of pound-feet lighter than is recommended in the manual, and that seems to be completely satisfactory. I nearly forgot to say that I also did replace all those bolts with new ones. I mentioned problems with the fit of the Chinese radiators earlier, and here we can see the hose barb on one of the radiators, the original radiators, compared to how it was on the new radiator, and it was completely unworkable in that state. So what I did was to insert a piece of rod that fit inside the hose barb, and then gently warmed it with a torch and pulled it back into a position that would work. Samco cooling hoses, yeah, quite pretty, I suppose. They advise you very strongly to purchase their, in inverted commas, special high quality hose clips, but really they're just regular Jubilee clips that may be made a little better. But the problem with Jubilee clips is that they do have that region alongside the worm where the clip will not properly conform to a hose, and so it isn't truly circular. I would much have preferred to use those sort of nip-on type hose clamps, and by nip-on I mean you have to use a pair of special pliers to clench them down on the radiator hose. Those are much more truly circular. But there we are. I used the special quality Samco Jubilee clips, and that's how it is. The next few slides show the wiring harness as I was making the best job I could of reinstalling what was, quite a mess. I guess this is normal for older machines that have been tinkered with a lot, and I did ultimately succeed in getting everything where it needed to be and getting the machine to run. So yeah, that's good. I nearly forgot to mention that you can actually see one of the block-off plates that I made for the secondary airports. So this is an example of the kind of thing that you may well have to contend with restoring an older machine. This one had had some kind of fairly nasty event in the safety logic for making sure you don't start the bike in gear with the kickstand down and all that kind of thing. The logic diodes in fact were, or what are usually called clutch diodes, were completely burnt out, and this piece of wire that came from the neutral switch was burnt, and when I looked at the end of it I thought, well, if it's burnt along that part it's much more likely to be burnt inside the loom where the heat can't get out. And I was quite correct, and I had to unwrap the loom all the way back to where the wire started and replace it all the way through. Anyway, it was successful, and it now works. One of the plastic lugs on the instrument head had been broken off, so here I've made another one which I glued into place, and that was that job done. The first suit of Chinese plastic fitted with the bike in its original colours. It's just as well that Chinese plastic is cheap, as you'll very soon see. At Carolina Motorsports Park, for its first and, as it turns out, last outing in this incarnation, seen with my Ducati 797 and my neighbour's Ninja 400. Unfortunately, during the day, turning into a left-hand corner, somebody decided to change line right in front of me, and I wiped out. Yeah, front end wipeout, very unpleasant and very hard. The bike took it more personally than I did. By Wednesday in the week after, I'd got the bike completely dismantled. In some ways it was sort of a strange kind of blessing, because I knew that the motor needed rebuilding completely, and so that's what I took on doing in the second rebuild. I discovered that the Honda rear axle would screw straight into the flywheel, and so with the aid of a weight on the axle I was able to pull the flywheel off very easily. I've seen people asking about the tool for getting the flywheel off. Well, apparently there seems to be one way of doing it. The first picture shows the main shaft, while the second picture shows the counter shaft. The third, fourth gear cluster is on the main shaft, and the dogs on third gear showed quite a bit of wear, which I understand is a weak spot with these gearboxes. Fortunately, that cluster is still available, so I replaced it. Earlier in the presentation I showed a view into the rear cylinder showing some scuffing. and be honest, it really didn't look too terribly awful, but I knew there was a problem, and having now got the pistons out, you can see the damage to this thrust face is actually quite bad. There's one particularly deep score that goes pretty much to the top of the skirt, just to below the oil ring, and that probably does explain why the compression on that cylinder was well down. Checking the main bearing oil clearance, and in both cases I measured 1/1000th of an inch, and the service limit is 1.9 thousandths of an inch. This is a good thing because the black bearing shells are no longer available, and I had to reuse the ones I'd got, and this seems to be satisfactory. I thought I'd taken a picture of myself checking the big end clearances as well, but unfortunately I cannot find the picture. But similarly they were perfectly fine, so yeah, I reused the shells I got. Free range tappets and shims. So here is a major reason why the crash I had turned out to be serendipitous, because when I took the rear valve cover off, I noticed one of the inlet cams was scuffing, and this after only 50 miles after putting the bike back together. I spoke to Roger Ditchfield, and his experience with this is that the first place a weak oil pump shows up is on the rear inlet cam. Now, as with so many parts for these bikes, the oil pumps are no longer available. Roger was able to provide a replacement set of rotors, and I'll talk more about that later on. Having said that about the scuffing of the one of the inlet cams, something I also did discover, perhaps not surprisingly, was that there was some debris in the oilway in that camshaft. I actually discovered when I stripped the motor down that there was a lot of debris in it. It was quite a mess. Fortunately, there didn't seem to be much in the way of damage, and I'm not really sure where all the debris came from, but it was certainly a good thing that I ended up stripping the engine completely and getting it properly clean. This is just to show how I affixed a drill bit in a length of dowel and used it to pass through the engine mounting locations where the frame sliders need to be, so that I could find the centres accurately in the fairing sidings. Here's one of the new JE engineering pistons, this one being in the rear cylinder. It's slightly twisted because the conrod isn't yet connected to the crankshaft, and the rest of the pictures are just general short block engine reassembly, Permatex and Molly on the gears. Here I'm installing a neodymium magnet into the oil pan drain plug. The oil pump plot thickens. I installed the first set of rotors that Roger sent to me, but unfortunately I found that there were 5 pinch spots per revolution, and they're just obviously not going to work. So I contacted Roger, and he agreed to send me another set, and I returned the first set for his evaluation. Upon receiving the second set, I worked on installing those, and I found that they were slightly tight width-wise, or perhaps depth-wise, in the oil pump casing. And so you can see here I'm setting the oil pump up in the lathe using an indicator capable of indicating down to 10 microns, and very, very carefully ensured it was running true, and also absolutely parallel to the axis of the lathe. And I then proceeded to take changing units 1/1000th of an inch out of the back face of the casing. Having done that, I installed the new set of rotors, and they were vastly improved, but there was still one small tight spot per revolution. Now this bothers me because if that causes the little drive chain for the oil pump to flog, eventually it might actually snap, and as far as I'm concerned that would probably be the end of the engine. Subsequent to all that, I received a notice from Roger saying that he has decided to replace every set of rotors that he sent out, and so I'm currently awaiting another set of rotors to install, and we'll see how that goes. I do just want to acknowledge Roger for his integrity in this process. I feel I should just say something about the condition of the end faces of the oil pump casing. They're pretty torn up, but the thing is about that kind of circular gouging, which is obviously from all kinds of crap that must have somehow got into the oil circulation system. It actually in a way forms a kind of labyrinthine radial seal, and so it's probably not tremendously significant in terms of the function of the oil pump. The important thing is just ensuring that there is enough overall clearance between the end faces of the case and the actual oil pump rotor, and so that's probably all I've really got to say about that. Showing using a long thin screwdriver through the special little opening in the top of the airbox to get onto that pesky screw right at the front that holds the first cylinder so-called velocity stack on. Part of the problem with this is that the hole that Honda have provided doesn't actually line up with the screw, and it really is a real bugger to get in there and get the velocity stack properly seated back onto the throttle body throat. So here's the Phoenix arising, or perhaps re-arising, and we can see her in the new livery with the exception of the tank, and just a picture of the decolon carton that the new set of fairings came in. That is the fairings that have the headlamp apertures blanked out. This bike, like nearly all of its type, has lost the original under tray from the tail section, and of course that means it's also lost the relay mounting tabs, and so here I've just fabricated a simple aluminum relay rack just to help in the process of tidying up the wiring. These LED tail light assemblies come typically with 3 wires. One is obviously common, one for run and brake, and the other for the turn signal. The problem with that is you actually need 4 wires in order to be able to get the distinction between run and brake. I opted to make my own 4-wire conversion kit because all that's involved is a piece of wire, some heat shrink and a resistor, the idea being that in the run mode you reduce the intensity of your light a bit, and when you put the brakes on you effectively short that resistance out and the light will bright up. Showing the indicated mileage at the restart after the full engine rebuild. The next clip shows the first start after the rebuild. Just flipping the throttle, keeping a close eye on the temperature gauge, and I continued to do that until it got fully up to temperature and everything was fine. Just admiring the beast, still with the original tank before I'd got around to getting the dents out of it and repainting it. Earlier in this slideshow I showed the installation and talked about the connection of the rear lights. The reason for this is I do want to be able to ride the bike on the road, in particular to be able to break it in properly before taking it for tuning on the dynamometer. So having the fairing with the blanked out headlight spaces, the question arises, what do I do about the front lights? What I came up with was a pair of these capsule lights, and conveniently on the front fork legs either side, there's a nice little flat pad with a M6 thread in it, and so I simply put an aluminum bar between the two and used it to mount these two capsule lights. So the one on the right is the regular sort of driving light, and the one on the left is the high beam. I have to say that they're remarkably effective. And so in the next picture we can see that I have indeed got the bike licensed and ready to ride on the road. And so it was time to take on an issue that I've been putting off, because I don't like anything to do with sheet metal work or body filler or any of that kind of thing. And even worse, I'm totally horrible with paint. But here we go, we had to take it on. One of the problems with the Honda tank shape is that it extends so far either side that if you drop it, the chances of catching the tank are extremely high. And so obviously when I crashed the bike after the first rebuild, I made what was already a slightly sad tank a whole lot worse. So I got hold of a Harbour Freight dent puller that uses hot melt glue, and I was able to pull the worst of the volume of the dents out, but that's as far as I was capable of getting. Beyond that, it was getting to work with filler, whatever you call that stuff, I can't remember now, and just keep on working and working at it, going over and over and over it until I got the shape and was left with no pinholes. After that, I did attempt to spray it, and I got a reasonable coat of primer on it, but I very quickly realised that I was not going to get any kind of a finish coat, and so I took it to a professional who colour matched with the fairing and put a finish coat on for me. What I was particularly pleased about was that I was able to save the Nicky Hayden signature. Yeah, it's not a Nicky Hayden special bike, but I do think that this tank is probably genuinely off a Nicky Hayden special, and so yeah, it's just something that gives the bike a little bit more interest value, I suppose. Well, as you might expect, this bike is particularly unforgiving on rough downshifts. Not that I'm particularly prone to doing that, but you know, every once in a while you can make a mistake, and that's probably when it is the worst possible time to do that. So I elected to fit a yo-yo dyne clutch. Show off, the yo-yo dyne beautifully showcased by a Scott Wolf clear clutch cover. I mentioned previously that the rotors on the R6 front wheel are 1 centimetre too small, and also they do not have the correct offset for the caliper positions on the RC51 fork legs. So after a bit of soul searching and thinking, I spent the money and ordered this pair of EBC rotors for an RC51, and I then went ahead and removed the buttons so that I could separate the rotor from the spider and create new spiders. I removed the buttons by grinding off the peened over head on the spring washer side, and then prized off the washer that engages on the spring washer. Then I was able to remove the buttons in their entirety. And what I did to install them in the new assembly was to put some aluminum bolts straight through the middle, and I made some brass nuts to replace where the rivet head would have been, and tensioned those down and Loctited them. It worked very well. It should be noted this actually probably isn't a full floating assembly, because the spring washers actually pretty much prevent the rotors from floating sideways. Yes, they'll move, and you can hear them tinkling a bit if you're rolling along with the engine stopped, but I guess I could have left the spring washers out altogether. But the brakes are absolutely fine as they are. I'm very, very pleased with the result. I spent a lot of time very carefully getting the dimensions for the EBC side interface and the R6 wheel interface, and was able to create an accurate drawing. And Seth Sinclair created a DXF file. I think it's DXF, I'm not sure. Probably got that wrong. Still, it doesn't really matter. And I bung that off to Cut Send, who can laser cut aluminum 6061 T6 in 3/8 thickness, which is pretty much perfect for this job. Here's the laser cut spider in my lathe, and what I'm doing is turning away the inside face where the rotor would interface to it to get the correct thickness for the buttons, and then transitioning down to create lands that meet up with the lands on the wheel hub. So here's the brake job coming to completion, and I'm very glad it went as well as it did. I really was quite intimidated by the prospect of taking this on. So I had the spiders powder coated, and then assembled the buttons and put the whole assembly on the wheel, obviously on both sides, and the spacing turned out to be perfect. I used EBC HH pads, and I have to say that the resulting brake setup is very, very good indeed. Extremely tactile, extremely sensitive, and also very powerful. Just what I need. So here she is, ready for the new engine to be broken in. I took the advice of Millennium Technologies and used a zinc-based oil for the break-in. And the way I went about breaking this in, bearing in mind that they are Nicasil bores, you need to get a lot of pressure of the rings on the bores to attain a good break-in. And so what I did was basically acceleration pulls, 100 miles pulling to 6,000, 100 miles pulling to 7,000 RPM, and so on, until I felt I'd done enough miles that I could consider the engine to be broken in. Here's the drain plug with its neodymium magnet after draining the oil from the break-in period. As you can see, there's a fair coating of sludge on the magnet. Couple of things to bear in mind. The neodymium magnet is very strong, and it's going to collect pretty much any magnetic particles that are floating around in the oil in the engine. And the second thing, of course, is that the break-in debris that will come off of the Nicasil bores is largely magnetic, being nickel. And so, of course, I think that most of this sludge is simply break-in debris that is magnetic, being collected by the magnet as it's supposed to be. So I see no reason to be concerned about this. I think it's entirely satisfactory. Results. I fitted the bike with a Power Commander 6, and I took it over to, I think it's Max Speed Cycles in Kernersville, to have it tuned on the dyno by Jim. Jim is very keen on the RC51, and he knows a lot about tuning them. Anyway, the result is 125 horsepower at the rear wheel, SAE atmospheric correction, and 68 foot-pounds torque. Pretty impressive. It's a strong RC51. What I was particularly pleased about, though, was how the bottom end of the torque curve filled out. This engine is extremely tractable. It really is. It's just gorgeous to ride. I like an engine that can give me torque absolutely anywhere without any fussiness whatsoever. And that's exactly what this bike delivers. And whilst it doesn't exactly have a top end rush, it's more than fierce enough for 65-year-old me. Well, if you've watched this through to the end, well done, and thank you very much indeed. I hope you found it interesting and possibly informative. And if you did indeed find it interesting and informative, perhaps you'd consider leaving me a like. Thank you very much.